Hello, everyone. Good afternoon. People are still filtering in, so we'll slowly start introducing this session. But welcome. Thank you for joining us. My name is Marie Renahan. I'm ERI's Engagement Coordinator, and I'm pleased to welcome you to our April webinar, Modernizing Steel Production, Assessing Opportunities and Impacts in Indiana. Before we begin, I'd like to mention that this webinar is being recorded and all webinar registrants will receive an email later this week with a link to the recording. Earlier this month, ERI published a report in collaboration with Five Lakes Energy that examined how modernizing Northwest Indiana's steel industry could grow the local economy, cut air pollution, and reduce greenhouse gas emissions associated with steelmaking. Northwest Indiana, of course, has long been a national leader in steel, producing nearly half of the nation's primary steel. Yet these coal-based facilities have been shedding jobs for decades and may be at risk of extinction without investments in modern, clean steelmaking technology. Our report took a close look at trends in the industry and identified several potential pathways to modernize each of the three steel mills in the region. They also modeled the economic and health ripple effects such an investment could bring to Northwest Indiana. Before I introduce today's speakers, I do have a couple of announcements to share. First, most people on this webinar probably know that next Wednesday, April 22nd, is Earth Day. This year, April 22nd also happens to be IU Day, a worldwide event celebrating all things IU. Here at ERI, we're celebrating both occasions this month by raising scholarship funds to support our McKinney Climate Fellows. These are IU students who are contributing to Indiana's resilience by partnering with communities, businesses, and nonprofits on sustainability projects. If you'd like to celebrate with us and support the next generation of climate leaders, please check out our crowdfunding campaign by clicking on the link in the chat. I also want to mention that our final webinar this spring is set for Wednesday, May 6th, and will cover ongoing work led by Hoosier Communities, ERI, and others to improve the health of urban tree canopies and plant hundreds of trees in neighborhoods where they deliver the greatest benefits. That webinar is being led by ERI Managing Director Sarah Mincy, and you can register for it through the link in the chat. Now I'm delighted to introduce our speakers. Today we'll be hearing from ERI Executive Director Gabriel Filippelli and Five Lakes Energy Lead Consultant Elizabeth Boatman, co-authors on the new report, Jobs in the Balance, Building Toward a Clean Steel Transition in Indiana. In addition to his role at ERI, Filippelli is a Chancellor's Professor of Earth Sciences and a biogeochemist with broad training in climate change, exposure science, and environmental health. Elizabeth Boatman is a broadly trained engineer specializing in industrial decarbonization. She works across all topics related to sustainable industry and manufacturing in the Great Lakes region, including hydrogen, steel, cement, and electrification technologies. If you have questions for our speakers, please enter them in the Q&A feature on the bottom toolbar, and we will try to answer as many as we can during the hour. With that, I will turn it over to our speakers.
Thank you, Marie, and thank you to everyone for joining us here today. We can go ahead and jump to the next slide. All right, so more than any other state except Pennsylvania, Indiana has an incredible steel legacy, and nearly all of it's tied to the shoreline of Lake Michigan in the northwest corner of the state. When we look at the built world around us, we don't always appreciate how much of it we can attribute to just a handful of industries, especially steel. Westward expansion in the 1800s, World Wars I and II, the construction of the interstate highway system were major drivers of America's steel might. Then layer on top of that the rise of the automobile, increasing demand for consumer appliances like refrigerators and washers, and you can see clearly that our economy here was literally built on steel. So Indiana's steel legacy became a part of this story in 1901. It's still with the construction of the state's first integrated steel mill, which produced bulk steel products from iron ore and coal inputs that were imported from other states in the country. But that 1901 facility isn't just a part of Indiana's history. As many of you probably know, it's still operating today. It's owned by one of the two vertically integrated steel giants in the United States, known as Cleveland-Cliffs. Just a quarter of a century later, the United States was producing a whopping 60% of the world's steel. By 1972, Indiana had two more integrated steel mills. They had started production in the exact same area as the first one, bringing the state's total to three high-volume plants that all rely on millions of tons of coal each year to produce millions of tons of high-quality flat steel products. Next slide. All right, so the previous slide showed an aerial close-up of the Gary Works steel mill, which has four operating blast furnaces. And here, you can see locations of all three operating steel mills in Northwest Indiana. So in the one satellite image that sort of has the little white arrows pointing, so you can see how close they are on the shorelines of Lake Michigan. The other thing I want you to notice in the images that show the facility specifically is the colors. Obviously, there's the blue of the water, but there's also brown. Those are unpaved areas without vegetation. They give rise to a lot of dust when wind blows over them. Rust, that's the color of the iron ore stockpiles, and black regions are coal stockpiles. The other thing you should look for is roads, lines that you can see that are roads that are actually interstate highways, small rectangles that are either city blocks or large industrial buildings, and you can even see the freighter-sized ports that serve each of these facilities from the lake. And I point this out just to underscore the scale of steel mills and their infrastructure, because it's not always apparent when we just drive by one on the highway. Okay, next. Unfortunately, faster than the nation's steel industry grew, it also started to contract. So by 1973, steel production in the United States contributed 2.1% of the nation's GDP. So that is one in every $50 of economic productivity in our country that was tied directly to steel made from American ore. In Northwest Indiana, this looked like 65,000 workers among these three steel mills. But that same year marked the beginning of a major inflection point for the industry as a whole, in our country in particular. The increase of industrial capacity in other countries, expansion of global trade, adoption of automation and manufacturing, and the emergence of new steelmaking technologies all started to cut into our steel sector's competitiveness. Despite the incredible loss of jobs and contraction felt by the industry in the half century since then, stability still doesn't appear to be in sight. Gabe will talk about this more in a few minutes. So the newest threat facing Indiana's steel mills are the cheaper, cleaner production offered by alternative technologies like direct reduction furnaces, such as the one shown in the picture right. And I'll talk more about this technology versus current technologies in a minute. But the main point is that the threat to Indiana's mills is cleaner, better technology, which they alternatively could adopt. And that's what the report looks at. Okay, next slide. I have mentioned coal. For every ton of steel produced from iron ore, a steelmaker needs about half a ton of a refined coal product known as coke or coking coal. This is produced at a coke plant, both of which Burns Harbor and Indiana Harbor steel mills have on site. But refined shouldn't be confused with clean. 2020 emissions records from Northwest Indiana steel mills show that these three steel mills collectively produced 135,000 tons of carbon monoxide, also known as the silent killer. That's why we have carbon monoxide detectors in our homes. Over 16,000 tons of sulfur dioxide, which can irritate respiratory tracts and eyes. 15,000 tons of nitrogen oxides, which can trigger asthma issues, and significant quantities of dust or particulate matter, which can contribute to a host of serious health issues like cardiovascular disease, stroke, and lung cancer. Based on modeling that's described in the report, we estimate that this air pollution directly contributes to roughly 75 million in healthcare costs each year, with greater costs borne by those living closer to the pollution centers. So the chart on the left in the figure compares the total of all air and water permit fines paid by Indiana's three steel mills to either item or federal EPA in a 5-year span, in comparison to the estimated collective healthcare costs due to the pollution produced by those three steel mills over the same 5-year period. And hopefully, as you'll note, there's essentially no comparison. We're talking less than $5 million in fines for a series of violations, toxic releases, compared to an estimated $375 million in healthcare costs over that 5-year period. Next slide. So this is what those violations look like if you stack them up in one figure. Some are repeated and unresolved problems, hence you see them carrying from one quarter to the next. And sometimes simply because the triggering issue, it may have been identified and resolved, but still led to a fine being assessed and required to be paid. So this is the record of those 5 years of permit violations that I was referring to in the previous slide that ultimately evolved to roughly $5 million in the total of fines paid. I don't have an exact figure on me, but I will say that in a given year, the two primary owners of these three steel mills, Cleveland Cliffs and U.S. Steel, their revenues as a company on the order of $1 billion. So these are on very different scales from each other. Next. To understand the full environmental impact of these three steel mills, we have to look at a few other indicators. So for example, these three mills also emit over 27 million tons of climate warming carbon dioxide each year. That's carbon dioxide itself, not just the CO2 equivalent. Some of those water permit violations are associated with heavy metal and thermal discharges and other toxic releases into local waters. Many of you are probably familiar with the news headlines those have captured in recent years. And none of these are good news for a region that also depends on ecotourism for its economic survival. You can see in the photo the industrial background from the image that otherwise was taken of a stunningly beautiful scene on the Indiana Dunes shoreline. Next. All right, it's a busy slide. We'll talk through it in a second. So the report lays out the case for modernizing Indiana's three steel mills according to two alternative technology pathways, and each of those also according to two different iron-making powering scenarios. The current production process, which has changed little in over a century, relies on a coal-powered blast furnace to smelt iron ore into metal iron at extremely high temperatures, with vortices of hot gas injections. And this is the pathway depicted in the left column labeled BFBOF, so blast furnace, basic oxygen furnace. This iron-making process is fundamentally what creates a tremendous amount of the air pollution that is exhausted from Northwest Indiana's three steel mills. That blast furnace-based process, all those pieces together, the swirling gas and the liquefaction of the ore and the coal, it's akin to lava temperatures. And as many of you probably know, your homes in winter, hot gas rises. So it pushes a lot of this pollution out the top of the furnace, and even with pollution controls, creates very large volumes of it. All right, so the blast furnace produces liquid molten iron. It is, like I said, lava temperatures. That's very, very hot. When it's tapped out of the furnace, it's then fed into another furnace called the basic oxygen furnace, and that's used to convert the carbon-rich iron into low-carbon crude steel. So by the mid-1900s, the electric arc furnace, featured all the way on the right, EAF, emerged as a key tool for recycling scrap steel. But there has been one problem with this furnace type for the decades since it emerged, because we haven't been able to feed it quality scrap, it can't make quality steel for use in specialty applications like cars. So for over half a century, even though we've had access to cleaner steelmaking technology, the EAF, these two technologies and their associated systems have operated more or less independently, with the recycled scrap produced by the EAF serving more of the construction market, things like rebar, and the integrated mills like in Northwest Indiana with blast furnaces serving automotive and other specialty applications. So in the middle, there's a bunch of other stuff going on. And the point here is that all of that I just spoke about, these two different production systems, selling into different markets, all of that's changing right now with the rapid scale up of a new iron making technology known as the direct reduction furnace, or DRI. Whether powered by natural gas or hydrogen and then heated to about half the temperature of the blast furnace, no longer melting the ore inside of it, the DRI furnace, as a result, produces much less pollution and far less greenhouse gas emissions for the same ton of iron product. What's more, the DRI furnace can now be coupled to an electric arc furnace to make automotive grade steel. As Hyundai Steel, if you follow news at all, is proposing to do at its new facility in Louisiana. So you may have heard about this. We would call this the DRI EAF production pathway. So the new thing is not just the new DRI furnace, which has really been around for several decades, but coupling it to the electric arc furnace. So in this case, the DRI furnace, which can't do the smelting work that a blast furnace does, and that's essentially purifying the metal to remove the gangue and other impurities from it. Now the DRI furnace can be coupled directly to either the electric arc furnace, or the other pathway you see featured is called an electrically heated smelting furnace, an ESF. So both of these are non-coal powered production pathways. And in this alternative scenario with the direct reduction furnace for iron making coupled to the electric smelting furnace, that also enables an existing integrated steel mill with a basic oxygen furnace for crude steel production to continue to use that furnace. So to continue to use some of its existing infrastructure. So point being, in the middle, those two pathways with the slash between them, these are our two modern alternative production pathways that are brand new in the market. And I really want to make this point clear. The production pathways, that is the chain of systems feeding each other at a single facility, are what's new. It's not the technologies. Both of these technologies, well, all the technologies have been around for decades at this point. So the point here is to give you the framework for most of the modeling and analysis that's presented in the report. Gabe and I aren't going to go into details on all of this here, but we're definitely going to share the highlights of the modeling results that were produced by considering these two technology pathways, and each with either a natural gas or hydrogen powering scenario for its iron making step. Only other thing to note is that not every pathway could be entirely considered in all the modeling we did in the report. For example, we don't have any facility pollution data yet for large-scale electric smelting furnaces. They have not actually, like I said, this type of facility doesn't exist at this scale yet. The technologies have existed independently. So because we don't have that pollution data, we can't yet model, for example, the anticipated facility air pollution. But we have worked with the data that is available to do the best we can for modeling. So next slide. All right, let's take a look at the greenhouse gas footprints of these facilities first. So each set of columns in the diagrams you see focuses on one of Northwest Indiana's 3 steel mills. Burns Harbor on the left, we'll start there. I want to walk you through the columns of data in order. So each color bar, so red, bright red, blue, green, represents the CO2 emissions from a particular aspect of production at the facility, like iron making or steel making. This is based off of self-reported data through EPA's greenhouse gas reporting program. So first, all the way on the left, you can see the 2023 actual GHGRP data for Burns Harbor, including the existing sinter plant and coke production that's happening on site. So it's important to note that none of these steel mills is operating at full capacity anymore. They're not efficient enough, and the demand for their products simply isn't there. That's why if Burns Harbor were to scale up to 100% production with its existing systems, its GHG emissions, just like Indiana Harbor and Gary Works, would rise. That's the second bar that you see. And we're calling that business as usual because it's still using the blast furnace pathway at 100% operation. The next 4 columns represent what we might expect to see for emissions reductions tied to the 2 technology pathways that I mentioned and their 2 different powering scenarios, whether natural gas or hydrogen for iron making. So here, you probably notice some of the color bars have disappeared in these alternative future scenarios. That's because we're assuming that sinter plants and coke production are phased out, but lime plants would stay. And the idea is that this would reflect actual shifts in production that we might be expected to see at integrated steel mills. All right, so if you look at the data, you can clearly see the potential for shifting the production scheme to cleaner technologies to also curb greenhouse gas emissions, especially if the DRI furnace is powered by clean hydrogen, in the charts identified as H2. So we see the same pattern at all of Indiana's steel mills. Their emissions could be slashed by modernizing the technologies that they're relying on for production. With the bulk of remaining emissions, if you look all the way at the cleanest and lowest, with hydrogen, DRI, the bulk of the emissions that are remaining would be possible to tackle by powering iron making with either the clean hydrogen or electrifying steel finishing processes. So that's the dark blue that you see carried through. Steel finishing processes that could also be electrified. All right, next slide. Hopefully it won't surprise you that we see similar patterns for air pollution reductions. So in this case, we're looking at a slightly different data representation. Each facility, if operating at 100% production using the current pollution-intensive technology, on the very left, and then how emissions would be cut by modernizing to either natural gas-powered DRI with EAF steelmaking, and then if you were to swap the natural gas for hydrogen. I just want to point out here that these three facilities and all of their air pollution are located within about 20 miles of each other. So if you can see, depending on what screen you're on, the numbers might look small, but on the left axis, that those are tons. So if we were to add up roughly the air pollution we see under business as usual, and again, here this is scaled to 100%, they're not operating at that right now, but current emissions, we would tally about 200,000 tons of health harming industrial air pollution from these three steel mills exhausted into the air each year in Indiana. Right, a passenger car weighs about 3 tons. Unless you have an EV, which some of you probably do, your battery pack is pretty heavy. But at about 3 tons, that's over 60,000 passenger vehicles worth of air pollution after emissions controls that are exhausted into the air each year from these facilities. So some of that air pollution, known as particulate matter, also settles out of the air, bearing heavy metals and carcinogens and can blanket plants with dust and even contaminate soil. So near the Dearborn Works steel mill in Michigan, for example, which like Indiana Harbor is also over a century old, the metal contamination of the soil due to industrial fallout is actually so high that local residents are told by the city not to grow their own vegetables at home in their gardens. All right, next. So remember, health harming air pollution contributes to health harms. Here you can see the potential to reduce certain health harms by modernizing to cleaner production methods. For example, simply swapping to natural gas powered DRI production could reduce ER visits for respiratory symptoms, asthma symptoms, lost workdays, and healthcare costs by more than half. All right, this is where I'm going to hand it off to Gabe to walk us through ERI's jobs analysis for these three facilities and take us into the economic aspect here. Thanks.
Thanks so much, Elizabeth. Can I have the next slide, Marie? Well, Elizabeth laid out very convincingly and clearly the various potential benefits of this transition, as well as very clearly the fact that the transition pathways are not pie in the sky. They're actually tried and true technologies that can be adopted. When we came to this report, when we came to this analysis, we were trying to we were concerned about environmental quality in Northwest Indiana from some of the emission figures that Elizabeth laid out, plus sustainability of these operations in the long term. We all want a vibrant communities in Northwestern Indiana, but we also want clean, safe communities, those that are not burdened by air quality exceedances. And also, as you'll see toward the end, ERI, has a commitment to being part of the solution to reduce climate change in the global sense. So I want to talk about the fact that local change can meet global needs, whether you're talking about the needs for steel, the need for clean steel, or the need to reduce carbon emissions. So I'll lay out a little bit the landscape of employment in the steel mills, both the direct jobs, those who are employed on site, as well as the upstream jobs, those that relate to the feedstock that comes onto these facilities, as well as some trends. what a clean steel transition might look like in some of those figures, and what kind of timelines we might be looking at. Um, we'll explore a little bit whether this transition, the demand for the transition, and the demand for cleaner steel products might come sooner than maybe some would anticipate or expect. Going to end up on a couple notes. One is that in this case, incremental change can work and might be actually a favorable way to go about making this transition. We're not talking about a whole-scale shuttering of plants and building brand new ones. This can be done in an incremental fashion. And finally, really, we can't talk about steel production and coal without talking about climate change and its impact globally, but more locally here in Indiana. Can I have next slide, please, Marie? Let's first talk about employment. The Northwest steel mills and the job they've been bleeding jobs for the last 15, 20 years. And that's, as Elizabeth pointed out, to competition, to producing at lower than max capacity and so forth. Not all of them have the same loss rate. Burns Harbor on the plot on the right, the green one, has lost a few jobs. Gary Works, on the other hand, has lost a tremendous number of jobs, just over a 10-year time span. In the report, we project forward for the next 10 years, and it gets pretty grim. Of course, you can't always predict future pathways based on past trends. But Gary Works, certainly at that loss rate, would indicate by 2034, which is not that long from now, zero jobs available. Obviously, there's probably some natural basement of job levels that you have to keep steel being produced. But the business as usual has been leading to this. It's been leading to a loss of jobs, um, and the continued pollution of Northwest Indiana. Go to the next slide, please. So the trends are troubling, as I mentioned, for all these facilities. Gary Works is particularly problematic, and I'm going to bring up an example about Gary Works in a couple more slides. But it's particularly problematic given how many jobs it's been losing, and this is across many parts of their facilities, I might add. So across a range of specialties. Can I have the next slide, please? So how about the upstream jobs? Those were the direct jobs. Those are the jobs in the last slide that were actually at each one of these mills that Elizabeth laid out and detailed. The upstream jobs, there's just simply not a lot of them. I mean, there are some, but these steel mills are fed by coal. And there are, on the order of 2,700 to 5,200 upstream coal jobs related to mining and shipping and so forth. So the business as usual trajectory, that's not going to increase any of these numbers, right? The business as usual will just keep these numbers static, assuming that you feed it the same amount of coke into each one of these mills every year. Those will remain static and relying on an industry, which is the coal mining industry, which is in itself on part of a very long-term decline, given the fact that there's many more clean alternatives that are more market desirable at this point. Kind of the next slide, please. So if we project forward, again, these levels, that the cumulative amount of jobs, which I'll show you in a couple slides, that's not likely to change. And so we're looking at business as usual being at best a static outcome, static in terms of the current employment, or at worst, continued decline. Can I have a next slide, please? So what does that look like? What might those pathways that Elizabeth laid out, what might that look like in terms of jobs in the future? And in this projection, we used the what we call this table has in blue on the left the three mills, of course, and on the top are the direct jobs for each one of these kind of scenarios. So look at the red, the business as usual coal red. The direct jobs are those that are currently employed at each one of these facilities. The indirect jobs are those related to service industries and doctors and community jobs that are in service to those direct jobs. And the upstream jobs are, for example, the coal mining and transport and delivery jobs that were present in the last slide. So I'm just going to take one example, Burns Harbor. That adds up to about 10,000 total jobs supported by Burns Harbor. When you look at any one of the transition pathways, so let me focus on the ones that we have the clearest numbers for, the ones we have good projections for that Elizabeth already showed. So the natural gas pathway and the green hydrogen pathway, you'll see that the upstream jobs just overwhelm the coal number of upstream jobs in coal. Uh, the natural gas and green hydrogen pipelines are critical because these are not just used to feed a steel mill, but they're also used for it can be used for other electricity purposes. And green hydrogen in particular has been a focus of a lot of conversations, just because it very well, at least for these facilities that require a tremendous amount of energy, it very well might be the hubs of the future. You've probably all heard of the potential green hydrogen hub in northwestern Indiana. That still exists as a potential. You can see the job total there is much higher than staying at business as usual. Can the next slide, please? So, as Elizabeth alluded to, uh, before I actually introduce fully this, that there are costs. The report lays out the costs associated with each one of these transitions as a comprehensive cost, as well as costs per facility, very specific costs. So the report actually lays out what this means in terms of the financial outlay, the construction costs, and the operating costs for each one of these mills. But what we're seeing is this continued pressure for cleaner steel on the parts of purchasers in the U.S., Europe, Canada. Auto industry is particularly has a large appetite for what's called clean steel, so a lower carbon emission steel, and almost all the new primary steel facilities, in fact, are built with this new technology. And some examples of these include the Hyundai plant that Elizabeth referred to, where they plan their own steel mill on site, where they're also going to be making the cars themselves. In Louisiana, one U.S. Steel expansion in Arkansas, several EU facilities, as well as some very unique and huge plants out of Sweden, which is also a steel capital of the world as well. A colleague, an ERI friend, just emailed me this morning, Larry Kane, who pointed me to a news report that just came out in Sweden about Stegra, which is a major green steel mill that's being built that's going to be fueled by green hydrogen to the tune of about 1.6 billion dollars, 1.6 billion, I'm sorry. And I'll put that number in perspective in just a moment. So that's to build a new green steel production facility. The strong signals that are out there are that capital is no longer flowing toward the blast furnaces, the technology of last century, but it doesn't match well with the needs and the health and climate concerns of this century towards some of these developing technologies. Marie, can I have the next slide, please? So let me pose a question. This is not a hypothetical. This is actually a question based on an investment that is going to be being paid out next month at Gary Works. They are building a $350 million refurbishing of only one, but one of their blast furnaces at Gary Works to get another 15 or so years out of that blast furnace. And that blast furnace will always has in the past burned coke, always will in the future. That's the only way they work, as you saw from Elizabeth's presentation. So the previous example from Sweden had a price tag of 1.6 billion to construct an entire facility that will be a facility of the future. Um, So is a $350 million reline a smart investment? Well, I don't know. I'll leave that to business people. But in terms of environmental quality, human health, and the climate crisis, I would argue that no, it is not, actually. The science actually points to that as well as laid out in the report. Sure, it will likely keep some facilities like Gary Works as places of employment for the jobs, same jobs that they have now. But here's the concern. What if they don't, what if it's not 15, 20 years that this investment will be good for, but what if the industry, this kind of dirty steel industry collapses in 5 years? What then? That you'd probably definitely rethink the $350 million reline as opposed to a $1.6 billion entire new facility. So, next slide, please, Marie. So the other point that we brought up in the report, we just want to make it very clear, and Elizabeth pointed out in one of the pathways to this transition, a transition steel facility is a renewable friendly facility, right? It's one for which the ample and cheapest form of electricity that's in the world today, solar photovoltaics like this solar farm, can be integrated into that, right? So solar, wind turbines, they're all part of this future, which these things can only be minimally incorporated into the current business as usual kind of steel production facility. But a transition facility that depends on electricity, this is very friendly. These kind of technologies are very friendly, especially when paired with battery backup, for example, or battery storage, I should say. Not only that, but you saw the size of some of these facilities that Elizabeth showed you from the satellite view. There's often ample real estate that's currently unused that one could imagine being viable locations for at least photovoltaics. If not, if the wind scenario is not, the wind modeling is not adequate to put large windmills out, wind turbines. Kind of next slide, please, Marie. So one can imagine in our scenario that we laid out, a transitioned steel mill where, yes, you keep some of the old systems online to continue making a profit, but you transition them over incrementally over years by building out things like electric possibilities, DRI technologies, building out solar fields. So slowly transitioning some of these steel facilities so that instead of having to transition them all, if they still exist in 15 years, 100%, you'll have already made the change and you'll already be producing clean steel for those purchasers for whom that's a big priority. Can I have the next slide, please? So at ERI, we'd be remiss in not actually considering a bigger picture as well, and that is the picture of the true costs of climate change. Elizabeth laid out very clearly the health costs of local air exceedances. So this is local pollution, both in the air, as she had great data for. The clearest health link between air pollution and health is in asthma. You know, asthma rates are exceedingly high in Northwest Indiana, largely owing to these large emitters. But the example that she pointed out in Dearborn, Michigan, where even soil is now unsafe for growing foods, is a concerning one, obviously. So, have the next slide, please. We are also, while making all these transitions, we're also transitioning our Earth's climate into a much warmer one. This is just simply the 10 hottest U.S. years on record, slightly outdated because now there's 2025, which also shows up in the 10 hottest years on record. This is no coincidence. Could I have the next slide, please, Marie? Uh, so we've seen this occurring for quite some time. The planet is warming. It's been warming at a kind of an increasing rate, particularly over the last couple of decades. When I used to talk about climate change, let's say in the late 1990s, early 2000s, we were still basing a lot of our science on the models of what it will look like in the future. But now the reality is here. We've all seen this in warmer weathers, earlier springs, highly variable weather, droughts, floods, heat waves, and so forth. The planet is warming. Could I have the next slide, please? And the physics tell us exactly why it is warming. That's because we're increasing the concentration of warming gases in our atmosphere. Uh, and again, physics would tell us that the only globe's response to that is to warm the atmosphere, which then warms the oceans, which was the last figure I have. So the planet is warming. We can tie all of that increase right there to industrial and commercial and personal emissions of carbon dioxide from fossil fuels like coal and natural gas. I wanted to make one point here is that a transition pathway that includes natural gas as part of it is is still more favorable than business as usual, where the product is based on coal, largely because natural gas has very few air pollution emissions related to it other than CO2. It is CO2, but it's at a less, it's not as great a rate as for coal. Nevertheless, natural gas is, maybe even just one of these transition pathways itself uh, to uh, to newer fuels like hydrogen and so forth. But so we've been seeing this trend. This captures nearly my entire lifetime in this one graph. It's rare that you see a graph that captures your life, but also the lifetime of my four children, for example. And the curve, unfortunately, has not bent downwards because we are still emitting carbon dioxide at a greater rate than we're taking it out. Can I have a next slide, please? And steel is no small part of that, frankly. There's no way to get around it. The figure on the right, the image on the right, is just simply the emission sources of carbon dioxide into our atmosphere at present. So you could see that agriculture is part of it, transport, driving your cars or flying your planes, and so forth. Buildings themselves are a significant component. But look at half of that pie wedge, which is power industry and industrial combustion and processes. A lot of that is driven by the fact that these are rooted and have always been rooted in fossil fuels. Uh, and this is so these are not small parts of the pie. These are half of the pie. The carbon pie is coming from these sources. And of that pie, if you look on the left of the industrial emissions, so that's taking that 21%. Another a quarter of that, a full quarter of that is iron and steel subsector. So that's a significant producer of fossil fuels. And that's because we have in the past and still now burn coal and coke to make that fossil fuel. I might add, we had a commenter earlier on before we did the webinar asking to see what the cement number is. So yeah, cement building structures is also a very hefty piece of this. But regardless, taking that pie wedge of steel and shrinking it would actually go a long way into reducing our global carbon emissions. Can I have a next slide? And that does not have our carbon emissions are not just a theoretical global warming. They actually are hitting us right here in Indiana, as anybody who reads the news can see. These aren't climate models. These are actually observations from the previous iteration of the climate change impacts assessment, of which we're doing a revision right as we speak. ERI is conducting an update. So particularly on the right-hand figure, you'll see the extreme precipitation events. Those have increased substantially and tied largely to climate change and this phenomenon that it exerts on the atmosphere called stalled low pressure zones. As what does that look like? What does that chart on the right look like? Could I have the next slide? This is what it looks like. This is one of two 500-year plus floods that hit South Bend, Indiana, just downwind of the steel mills that we showed you, that hit South Bend, Indiana over 2 years in the last decade. And these were extreme flooding events caused by this change in extreme rainfall. This slide, I like to show a couple things with it. One is that there's a lot of flooding, duh. The other is that flooding is impinging on properties, which cause property damage and human health impacts from mold exposure. The third is that flooded pathway in the middle. Well, that's a major roadway, which is now a flooded access point for which emergency vehicles can no longer get down. So it has the potential to disrupt life-saving capabilities. Fourth and finally, that fenced thing that you see in the foreground is actually a cleanup. It had been a cleanup in former recreation site actually, and the fencing does a great job of keeping people out, but not a great job of keeping water out. So the slide shows kind of many of the aspects of flooding and climate change that we're actually living through right now, and we're not living through it theoretically because of some future model, but because of our current carbon emissions. So doing the global right thing is actually doing the local right thing as well. Can I have a next slide, please? Um, didn't even have to look at last decade. This is yesterday. Massive flooding that's occurring on the shores, particularly the western shores of Lake Michigan, impacting communities and shorelines up and down Lake Michigan and Wisconsin and Michigan. So yeah, again, not just 10 years ago, but April 14th and probably likely into 15th. Come to the next slide, please. So uh, one aspect of the climate change that we're already feeling here in Indiana is an expansion of vector-borne diseases from this combination of more flooding and warmer winters that combine to increase the range and the disease carrying capabilities of ticks and mosquitoes in Indiana. These so-called tropical diseases that are carried by mosquitoes, we're seeing them in Indiana, as well as a significant expansion of disease, Lyme-related bites and Lyme disease. Go to the next slide, please. This transition pathway that Elizabeth laid out is very much part of the story of the fact that the future is not, we are not hapless victims in our climate future. We actually have control over the volume knob. And this transition, this steel transition, is one of many of these large scale transitions that we simply need to seriously consider if we want the volume to go from out of control screaming climate change in 2100 or one that is tolerable and for which we can adapt and adjust. Um, so with that, Maria, I'll have you advance to the next slide, and I think we will be open to some of the questions.
Wonderful. Well, thank you so much, Gabe and Elizabeth, on this amazing presentation. We've already gotten a number of wonderful questions in the Q&A that Elizabeth has been contributing to. But I'll summarize one or two of them, and then if anyone has additional questions, please keep adding them to the Q&A. We can also go back to some previous ones if anyone wants to add more information on those. So I'm seeing a lot of questions kind of surrounding accelerating this process of transition and how do we get these transition technology pathways into steel mills quicker. Is this something that policy is the linchpin in? Is this something that unions can contribute to, the need for additional workers? What is the biggest limiting factor in getting us moving forward in this transition?
I'm going to say briefly, and I turn it straight over to Elizabeth. One of the ways that we've always seen as an incentive to moving forward to newer pathways, for example, are federal incentives. So if regulation doesn't do it, for example, if you, like Elizabeth showed that regulation's not doing it, right? These air quality exceedances, they have to pay fines, but they're a tiny little piece of a massive profit, right? They're not doing it alone. So that's often various federal or state level incentives can help bridge that gap. It's the gap of death. This technology transition that we all want, but it doesn't pay next year, but it will in 3 years. Well, you need to figure out some way to get over that hump, and often it's investments that were present in, for example, in some of the bills that passed in the last administration. Elizabeth, I'm going to hand it over to you.
Yeah, in general, my answer is all of the above, even the things you didn't mention. But yeah, I saw one of the questions too about union engagement. So while Gabe and I, that hasn't been our role, there are community organizations in Northwest Indiana who some of them are actually ex-steelworkers. They were the unions, and they have done their best to engage the unions. There's a variety of reasons why engaging unions has been challenging. This is not the only state where I work in steel. I've also provided technical support to a couple of other similar nonprofit organizations in other states who've also been looking to figure out what to propose for their steel mills. And they all report challenges engaging unions. And the simple answer, truthfully, as I understand it, is that relining a blast furnace tomorrow, right? Gary works. There is a planned reline starting in May. That's basically tomorrow. That guarantees jobs now. It guarantees those jobs will be here in the next few years. And potentially, since every reline, so it's a major servicing appointment for a blast furnace to keep it functional. You strip out all the bricks inside, put new bricks in, it keeps operating. But that reline enables that furnace to operate for another 15 to 20 years. And to many of the unions, that looks like guaranteed jobs for 15 to 20 years. Whereas what we're proposing, it's an unclear path for them. If the company's not going to invest or saying that maybe that's not actually the right production system for the facility, that feels shaky. So it's really understandable that right now many of the unions are still pretty aligned with the companies, despite the clear health benefits that would come not just to communities, but also workers on site who are not being exposed to as much pollution. But yeah, getting union engagement has been a consistent challenge that I've heard from folks all around the country. Indiana is not the only state with integrated steel mills like this. But I think on our end, to the point of what Gabe has laid out in terms of the jobs aspect with unions in particular, I don't think you can say that just because the blast furnace receives the servicing appointment, the reline, that would enable it to function for 15 years, that guarantees jobs for 15 years when the market conditions are actually changing very rapidly. And the cost of the reline is significantly lower than the revenue that would be generated from the facility in 1 year, as in it could pay for itself in a year. So it does not guarantee those jobs for 15 just because it's invested.
Great, thank you both. There have been a few questions on what we talked about pairing these emerging technologies with solar, with a few different options for renewable energy. But there's some questions on green hydrogen. Is it a legally allowable source of energy in Indiana? And then there's also one on geothermal. Can geothermal be used as one of these green renewable energy sources with the steel mills?
I typed one live to our friend, our ERI friend Denise. Yeah, geothermal could be. In fact, I've seen that proposed in the past. But the hydrogen issue, I don't believe it's outlawed or anything like that. Because they tested out actually hydrogen. Elizabeth, correct me if I'm wrong. I believe they tested that out at one of the facilities in Northwest Indiana. Is that correct?
So it would have been the hydrogen, gray hydrogen already produced at, I forget if it's Linde or Air Products, but right there by the BP Whiting refinery. And the other question was about, oh, you answered geothermal and then the green hydrogen part. But yeah, so hydrogen itself, there's, to my knowledge, nothing currently prohibiting it. And in general, we're thinking are like pipelines appropriately permitted, right? Is safety really, you want first responders appropriately trained, et cetera. So it's a different set of system constraints to get it up and running than it is for something like a new power plant, for example. But yeah, there's no explicit barrier to it right now other than the economic aspect.
Great. There's a question on healthcare costs. So you mentioned a $75 million healthcare cost associated with sticking to business as usual. Does that include, what types of healthcare costs does that include? Premature deaths, cardiovascular disease, cancers? How comprehensive are we looking for that cost assessment?
Yeah, so Industrious Labs supported us with this part of the modeling work, and there's some description in the report about essentially how that was carried out. But the short answer to that would be the EPA also produces the COBRA tool. And so that is a health impacts assessment tool that quantifies, starting with the air pollution records, essentially what healthcare costs likely fell out of that. And so the reason why I'm not directly answering is because most of these are covered in that. I cannot remember explicitly if the way that's described includes like neurologic diseases. I don't recall that being part of what is considered, but certainly like cardiovascular, lung issues, premature deaths. I think that we took out infant mortality and focused instead on the premature death aspect. But this is described in the report. And if it doesn't feel like it's described well enough, there's also a link to Industrious Labs' Dirty Steel Clean Air report previously published that describes their methodology a little more in depth. And then also EPA Cobra's website further clarifies everything that's factored into their modeling work.
Wonderful. One question is about market transition and how it might influence these companies. Essentially saying that US Steel will not be competitive globally without transitioning to a lower carbon footprint. So how much is the market influencing these processes internationally and nationally?
So there's two things. One is right now, some of the facilities that I talked about, like Hyundai Steel, it's not up and running. It won't be for several years. So at the moment, it's not part of the market, right? It's out there, it's coming, but it's not part of the current market. So clearly, what we're already seeing is that American steel production is heavily impacted by steel production in other countries, whether it's recycled steel or primary steel products. Generally, folks will say that the worst thing for steel around the world is the fact that in China, they can produce so much and they can literally dump it into the market below what it costs them to produce it. And so that cheap steel floods not just our market, but Europe and Australia and other countries. So that's part of the current story and why we're seeing production levels at our current mills dropping because they cannot produce the same quality steel for the same cost point. So it's cutting into their market share. Now, flip side is in 4 or 5 years or so, when Hyundai Steel and the rest of Big River Steel come online, that this will further compete with Indiana's steel mills as well as the others that are still blast furnace based. And it's not just because lower carbon footprint, it's because it costs less to operate a furnace that operates at half the temperature. It's half the energy inputs.
Which is a great analogy to to what we've seen with solar. Yeah, solar was a heavy lift 10 years ago, 20 years ago. It's not anymore. It's simply cheaper. So it's the same kind of pathway future. And again, for Northwest Indiana, it would be one thing if the product from these steel mills was just carbon dioxide that impacts global climate. That's a concern, obviously. But the fact that it also impacts local health and the local economy in a negative way, and ecosystems. We didn't. Our report discusses that a little bit, but it much like transitions to renewables, it's the right thing to do. And maybe I guess what the report's laying out is maybe this is the right time to seriously be considering this. And in fact, for the companies themselves, maybe to start engaging in conversations around this transition.
All right, with that, I think we are ready to wrap up. Thank you again, Elizabeth and Gabe, for this amazing presentation. For all attendees, we will be sharing a recording of this webinar, and all recordings of our past webinars are available on our YouTube channel. So please give us one last hand for our speakers, and thank you so much for joining us today.
Thank you.
All right, bye everyone.